Hello everyone. In this video, I'm going to present Panopto Interactive Learning Model. This is to develop metacognitive skills via interactive media. Metacognition is about self-regulation on monitoring and controlling one's thinking process. Metacognitive skills are useful in the learning of almost all subjects. Students' ability in using metacognitive skills affect their performance in solving math problems because they need to know the requirements of a problem and to apply the relevant method. To facilitate students' learning of metacognitive skills, using prompting questions is proved to be an effective strategy. Being guided by prompting questions, students can learn to develop their own strategies and procedures in solving math problems. The objective of this study is to develop a teaching model to facilitate students' metacognitive skills in mathematical problem solving, while Panopto, a media tool with interactive features. What sets this model apart from the existing models is the interactive features. The research shows that by embedding prompting questions into videos, a lecture video is broken into learner-controlled segments that increase learner engagement. The learner content interactions make learning more effective than watching a lecture video in a passive manner. Panopto is particularly suited for this purpose. Firstly, it's easy to access. Secondly, it's a media tool with interactive features. Thirdly, statistical analytics can be used for continued improvements. Here are the teaching strategies. A lecture video on solve a complex math problem was recorded. Then the prompting questions were inserted via Panopto. Following the prompting questions in the video helps students progressively develop familiarity with metacognitive strategies. After some time of practicing, students are getting more and more competent in using metacognitive skills. Here are the examples of prompting questions. Participants in this study were students from Australian matriculation consisting of two groups, April intake and July intake. Two groups were both taught the use of metacognitive skills on sketching graphs. April intake students were asked to watch the recorded lecture video without interactive features, and the July intake students were asked to watch and respond to the interactive features inserted in the lecture videos via Panopto. April intake students took the assessment on 11th of July. 26 April intake students' papers were collected. July intake students took the assessments on 13th of August. 28 students' papers were collected. According to Panopto Analytics, 17 students watched and responded to the interactive features of the lecture videos. The other 11 students didn't watch the video. The results show that the mean marks obtained on the graph sketching by students who watch and respond to the interactive features are higher than those who don't. The unpaired t-test also indicate a significant difference between July intake students who watch and respond to Panopto videos and those who didn't. Also between the July intake students who access interactive media and April intake students who didn't. Feedback from students show that they generally believe videos with interactive features made the learning more engaging than videos without the interactive features. In conclusion, the proposed interactive media made a significant improvement in developing students' metacognitive skills and their mathematical problem-solving performance. The metacognitive skills developed through this approach can be transferred to other learning situations and subjects, especially when facing complex real-world scenarios. Metacognitive skills allow students to organize and evaluate their thinking process related to problem solving. Thank you. And here is the reference.